Hokie dokie. In this problem, they give us some information about bears, otters, and salmon. To summarize it, the bears and otters both prey on the salmon. The salmon are at the bottom of this food chain. Bears will also occasionally prey on otters. That's pretty much it. So what we're looking for in this case is the rate of change of the salmon population, represented by S with this apostrophe, and we call that S prime. So anytime you see S with the apostrophe, that means S prime, which means the rate of change of whatever that function is, in this case the population of salmon. So we want to find the correct representation for the rate of change of the salmon. So to make some sense of what's going on here, it's a lot to look at. However, we want to find the equation that basically says if there are more bears, then the salmon population should go down. If there are more otters, then the salmon population should also go down. So we're looking for B and O to have negative values in front of them. So in option B, we see B has a positive value in front of it. This cannot make sense because that's saying if there are more bears, then that's going to increase. It's going to have a positive effect on the rate of change of the salmon population. So this makes statement B false. Looking at option C, there is a negative where the bear population is, which is good because it's saying the more bears there are, the less salmon there are going to be. It's going to have a negative effect on the amount of salmon. However, when where we see the O, the otter representation or otter population, it has a positive next to it. So what that's saying is the more otters there are, the higher the salmon count is going to be. It's going to have a positive effect on the salmon. But that's not right because otters also prey on the salmon. So this makes C false. And then when we look at D, it looks like B and O, the bears and otters, have a positive effect on the amount of salmon, which can definitely not be right. And so we want to pick the answer that has a negative in front of the B and negative in front of the O, because that's telling us that the salmon population is going down if there are more bears and more otters. And that's practically it. And then just because salmon are at the bottom, the more salmon there are, that is going to have a positive effect on the number of salmon. So what I'll go ahead and do is the other two examples you might see. So this was S prime, the rate of change of salmon. This will be the rate of change of otters. So otters are kind of in the middle. Bears prey on otters, but otters also prey on salmon. So we want to make sure that first the bear count is having a negative effect on the amount of otters, because if there are more bears, then there will be less otters. So because this bear value is positive in front of the 0.7, this makes this wrong, right? So then we see that the same thing happens here in option D. Bears has a positive coefficient, so this makes option D incorrect. So now looking at options B and C, it says that bears have negative effects on the otters population or rate of change, which is good. So we also want to see something like the salmon having a positive effect on the otters rate of change or population change, because the more salmon there are, the more chance otters have to feed on the salmon. So in this case, we see a salmon count having a negative effect on the amount of otters. That can't be right, because the more salmon there are, the more otters will get to eat. So this makes option B incorrect. And then option C has salmon with a positive amount. So the more salmon there are, the more otters there will be, because they'll have more chance to feed on the salmon. So C is looking like our best answer. And then the issue is whenever you have predators, the more predators you have, in this case, the more otters you have, the more competition the otters will have to, prey on the salmon. So the more otters there are, in other words, will have a negative effect. Because if you have too many, predators fighting over the same salmon population, it's just going to make the otters go down. Not everyone's going to be able to eat. All right. In the last one, we're looking at the bear rate of change. So bears are at the top, so anything they eat will be, or like any other lower population, so like otters and salmon, should have a positive effect on the bear's population. So anything with negatives in front of otters and salmon can't be right. Salmon is positive here, but otters are positive there too. So B is looking okay. We have otters, we have salmon, both positive here. That's probably a better look. And then we have otters being negative, which can't be right. So looking at B and C, to follow kind of the pattern we've been seeing, where it's always like two letters multiplied by one another, so it's like B times O times S. We probably won't ever pick any that just have like a loose O in the mix. And so it looks like the number of otters has a positive effect on the bears. The more otters there are, the more bears will be able to eat. The number of salmon, the more salmon there are, that'll have a positive effect on the number of bears, because bears will get to eat salmon. But then it has that same effect at the end, where if there are too many bears feeding on the same prey, then there's going to be competition, so the number of bears might go down if there's too many bears, ironically. So C is our best answer of that representation. I really hope this makes sense. Basically, as long as you recognize these different examples, these will be a good format for really all the examples you'll see, if that makes sense. So like this is all you'll look for, with these certain values being positive and negative every time you see this problem. All right, hope this helps. If you have any questions, let me know.